You are welcome to this module of Home Tutors. This module is known as Mensuration. And in this module, we have sections, namely perimeters, areas of plane shapes, area and volume of solids. But in this particular section, we will be looking at the first outline. Perimeter. What does it mean? What are the equations for finding the perimeters of common objects? These are the things we will be looking at in this first section of the module Mensuration. Okay, now to some basic definitions. What does perimeter mean? Perimeter of a plane shape is the distance around the edge of the shape. This is a rectangle, for example. The distance around the edges of this rectangle is length plus breadth plus length plus breadth. So the perimeter of a rectangle is given by 2 into length plus breadth. This is a circle. The perimeter of a circle of radius r is given by 2 pi r, where r is the radius of the circle. It can also be given as pi d, where d is the diameter of the circle. Note that the diameter of a circle is 2 times the radius. That is, d equals to 2r. Also note that the perimeter of a circle is also known as its circumference. So, either you are told to find the circumference of a circle or told to find the perimeter of a circle, they are referring to one and the same thing. And here, this is an arc AB. And this is a sector OAB. So, to calculate the length of this arc, which subtends an angle theta at the center of the circle, it is given by the equation 2 pi r times theta divided by 360. That is if theta is given in degrees. The length of the minor arc AB is given by 2 pi r theta divided by 360. That is if theta is given in degrees. And the perimeter of the sector OAB would be the length of this arc AB plus the distance OB plus the distance OA. But note that the distance OB and the distance OA are equal to the radius of the circle. That is, OA is r, OB is r. So, the perimeter of the sector OAB will be equal to r plus the length of this arc plus r. That gives us 2 pi r theta over 360, which is the length of the arc, plus 2r. 2r coming from OB, which is r, and OA, which is also r. These are important equations which you need to learn by heart. And pi is a symbol representing the value 22 over 7, or approximately you can use 3.14. Example, find the perimeter of a sector of radius 3.5 centimeter if its angle is 144 degrees, like in the figure on your screen. This is the arc AB. This is the radius, 3.5 centimeters, and it sustained an angle of 144 at the center of the circle. So, recall, we are told to find the perimeter of the sector. Recall, perimeter of sector is 2 pi r theta divided by 360 plus 2r. Therefore, in our own case, Perimeter will be 2 times pi times radius, which is 3.5, times 114 degrees divided by 360 plus 2 times radius, which is 3.5. That gives us 8.79 plus 7. And that gives us perimeter of OAB equals to 15.79 centimeters. Example 2. Find the circumference of a circle with diameter of 20 centimeters. As you can see on your screen, a circle with diameter of 20 centimeters. Find the circumference. Quickly recall that circumference is the same thing as perimeter. And recall that the perimeter of a circle, when you are given the diameter, is given by pi d. Therefore, in our own case, we have perimeter is pi, which is 3.14 times the diameter of 20. That gives us a perimeter of 62.8 centimeters. Example 3. The minute hand of a clock is 10 centimeters long. How far does its tip travel in 24 hours? So, let's assume this is a clock. This is the minute hand. Recall that the minute hand makes a full revolution in 1 hour, which is 60 minutes. So every 60 minutes, that is every 1 hour, the minute hand of a clock makes a complete revolution. Now, watch this animation. This is the minute hand moving, and by the time it gets here, it's in 60 minutes. You see, every 60 minutes it makes a complete revolution. Now, recall that the perimeter of a circle is given by 2 pi r, where r is the radius and theta is in degrees. You remember, perimeter of a circle, 2 pi r. Therefore, the distance covered by the minute hand when it makes a complete revolution, that is the perimeter of the circle around which the minute clock revolves, is given by 2 pi r, which equals to 65.94 centimeters. What that means is that, you remember this animation, this is the minute hand. As it revolves about a fixed point, it is making a circular trace. So the perimeter of the circle traced by the minute hand is what is given by 2 pi r. Why? Because the length of the minute hand is 10.5. So the perimeter of the circle that the minute hand traces is given by 2 pi r, which is 65.94 centimeters. And something about this perimeter is that it is also the distance traveled by the tip of the minute hand every 60 minutes. That is, every 1 hour, the minute hand covers a distance of 65.9. I hope you understand, because it takes 1 hour for the minute hand to make a complete circular revolution. So that means every 1 hour, the tip of the minute hand covers a distance of 65.94. Now the question is, how far does it travel in 24 hours? So, if in 1 hour it travels a distance of 65.94, in 24 hours it's going to travel a total distance of 24 times 65.94. Do you understand? That is to say, the total distance covered by the minute hand in 24 hours is 24 perimeters of the circle, because in 24 hours it will make 24 complete circular revolutions. So if one complete circular revolution has a distance of 65.94, 24 of such revolutions would have a total distance of approximately 15.83 meters. Usually it is 1582.6 centimeters, But take that to meters, will give you approximately 15.83 meters. Example 4. Through what angle does the minute hand of a clock move in 25 minutes? Note that one complete turn of the minute hand is 60 minutes. The minute hand makes a complete revolution every 60 minutes. Watch this animation. Now, this is the face of a clock. This is 12 o'clock. This is 1, 2, 3, 4, 5. So this is 5 minutes past, 10 minutes past, 15 minutes past, 20 minutes past, 25 minutes past. So by the time the minute hand moves 25 minutes, we are asked, what is this angle that it has made? Now, note that from the principle of proportion, 60 minutes, that is movement from here to make a complete revolution, is what constitutes 360 degrees. So, if every 60 minutes the minute hand makes 360 degrees revolution, how many degrees will it make in 25 minutes? From the principle of proportion, we have 25 minutes will be equal to 25 divided by 60 times 360. That will give 150 degrees. I hope that is clear. If from here all through here we give 360 degrees, then from here just to this point we give 150 degrees by the principle of proportion, because the minute hand will make 360 degrees in 60 minutes. So 60 minutes is equivalent to 360 degrees. So 25 minutes will be equivalent to 25 divided by 60 times 360. That gives 150 degrees. Now, an additional question. If the minute hand is 6.3 centimeters long, how far does its tip move in 25 minutes? So we are saying this length of the minute hand is 6.3 centimeters. What is the distance it covered within that space of 25 minutes? This is just like finding the length of an arc, which subtends an angle of 150 at the center. This question is simply asking you for the length of the arc in the figure above. Recall, equation for finding the length of an arc is 2 pi r theta divided by 360. So in our case, we have 2 times pi times radius, which is 6.3, times 150 degrees divided by 360. That gives us a distance of 16.5 meters.